Okay, Oak Rovers, this is going to be a video to help you with the con exercise, difference of squares 3. Let's look at our first problem. The first problem is 20x squared minus 125. Now, I do have a difference here because I'm subtracting two numbers or two quantities. The first quantity is 20x squared minus 125. But the problem is that 20x squared isn't a perfect square, and neither is 125. So what I'm going to have to do in a problem like this is actually factor something out first and see if I get a difference of squares after I factor that something out. Now 20x squared and negative 125 are both divisible by 5. So I'm going to factor a 5 out of that problem. When I do that, I'm going to get 5, and then inside the parentheses, 4x squared minus 25. The reason I'm able to do that is because 5 times 4x squared is equal to 20x squared, and 5 times negative 25 is negative 125. So let's look what's inside the parentheses, and 4x squared is a perfect square, and so is 25, and let's put them into my generic rectangle. So I put my larger cubes, my x squared cubes in the bottom left, and my unit cubes in the upper right. And I have the 4x squared there, negative 25 up here. Now these two boxes here have to add up to 0 because I don't have a middle term. I have 4x squareds, I don't have any x's, so I'm going to have 0 in the bottom of my generic rectangle. Or excuse me, of my diamond problem. But these two boxes, they have to add up to 0x, but they have to have a product of negative 25 times 4, which is negative 100x squared. Now let's look at this. In order to get a sum of 0, I have to add two numbers together that are opposites of each other. And 100x squared is a perfect square. So I can factor out a negative 10x and a positive 10x. Because if I multiply a negative 10x times a positive 10x, that's how I get the negative 100x squared. Let's put those numbers into my generic rectangle. And when I do that, then I can factor something out of this bottom row. 4x squared and 10x both have a common factor of 2x. If this dimension is 2x and my area is 4x squared, this dimension has to be 2x. If this dimension is 2x, that means that dimension is 2x. And if my area is negative 10x, this has to be minus 5. If this dimension is 2x and my area is 10x, this has to be positive 5. Which I have a hard time finding. There it is. So it's positive 5. Now, let's write that as a sum and a product. My sum is 20x squared minus 125, and my product is going to be 5 times 2x plus 5 times 2x minus 5. The 2x plus 5 comes from that dimension, and the 2x minus 5 comes from this dimension. Now I want you to look closely what's inside the parentheses. What's the square root of 4x squared? It's going to be 2x. And what's the square root of 25? It's going to be 5. So this problem fits the formula a squared minus b squared equals a plus b times a minus b. But I just have that 5 out because I factored that 5 out before I did the problem. Let's look at one more problem and see how it works. Now this one, 18x squared minus 50, I can factor a 2 out because they're both even. After I factor a 2 out, I have a perfect square minus another perfect square inside the parentheses. So let's put my 9x squared down there, my negative 25 up there. These two boxes have to have a sum of 0 because there's no x term. They have to have a product the same as this. If I have 9 quarters, I have 225. So it's going to be negative 225x squared. That's a perfect square. 15 squared is going to be 225. So I have a positive 15x and a negative 15x. Clicked on the wrong boxes, but I have a positive 15x and a negative 15x. So let's put those in those boxes. And on this row, I can factor 3x out. If this dimension is 3x, and my area is 9x squared, that has to be 3x. If this is 3x, my area is negative 15x. That's got to be minus 5. If this is 3x and my area is 15x, this has to be positive 5. Now I could have probably have looked at this inside the parentheses and realized that the square root of 9x squared is 3x, and the square root of 5 is 5, or 25 is 5. So I could have been able to see that 18x squared minus 50 is going to be equal to 3x plus 5 times 3x minus 5 plus, or times that 2, which I factored out originally. So it's 2 times 3x plus 5 times 3x minus 5. Hopefully that helps. Remember, in difference of squares 3, you're going to have to factor something out. And after you do, you'll be left with a perfect square inside these parentheses.